Eric Darling here with Darling Data, and we are going to continue our magical demystifying tour of SQL Server stored procedures. And in this one, we are going to talk about another thing that comes up quite a bit, and that is the use of local variables in stored procedures and how they can have strange and profound effects on many things. I realize that this is a topic that has been well trod on this channel, but again, in the interest of completeness for a series about stored procedures, I'm doing a video about it here. And also, this is a topic that I cannot get away from. Just this past week, I was on a call with 4 senior developers for a fairly large company, and they were all puzzling over why this store procedure was suddenly acting up. And when one of them decided to share their SQL Server Management Studio window with me, well, what happened was not a store procedure. Of course, it was creator alter procedure was quoted out. The parentheses around the 2 or 3 parameters for the store procedure were quoted out, and the little parameters that they had, a few parameters that they had a little declare inserted above them, and they had some values assigned to them. And they would hit F5 and have no idea why this thing was suddenly a lot slower than when they were testing it for some QA thing. And of course, we had to have the talk about the birds and the bees and the local variables. And as soon as it was executed as a store procedure, everything was back to normal again. It's a rather long store procedure, so I didn't want to have them go through and put option recompile hints on every statement, because that would have taken a long time to do and then undo, and then they probably would have had perhaps a new bad habit formed for them. But it was demonstrative enough to just execute as normal. Now, what we're going to talk about in this one is some of the okay uses of local variables, some of the not okay uses of local variables, how to tell when local variables and other similar constructs, namely the optimize for unknown hint, are causing problems, and of course, how to test code that is parameterized appropriately. So we've got quite a rundown here, and hopefully we can do it all before the heat death of the universe or something. If you enjoy this content, if you are gung-ho on what me and Bats cook up in the kitchen and bring to you here on YouTube, you can sign up for a paid membership. We don't get anything extra. You just say, thanks for doing a good job. It's a little tip jar for me to keep doing these things. Link in the video description. $4 a month. Entry is the entry fee on that. You can, of course, go higher if you are feeling generous at all. If you are short the $4 a month, perhaps because, I don't know, maybe you spent it all on collectible Pez dispensers or the actual Pez that goes in them, that's fine. I understand financial hardship, especially if you're a government employee. Might be having a tough time recently financially. You can do other things to support the channel. You can like, you can subscribe, and you can comment. Just be nice. Some of you leave crappy comments. And if you want to ask questions privately that I will answer publicly in my office hours videos, in which I answer 5 user questions at a go, you can go to that link, which is also down in the video description. Make this tremendously easy for you. If you need help with your SQL Server, even if you are a government employee, I will help. Will help anyone who writes a check. We can do any one of these things: health checks, performance analysis, performance tuning, like actually fixing problems, not just someone standing there telling you everything you've done wrong, but actually helping you fix things. If you are having a performance emergency, or if you need training so that you do not cause any future performance emergencies, the Easiest fire to fight is one that never starts, right? I am available for all these things, and of course, as always, my rates are reasonable. If you would like some training to get better at SQL Server performance tuning, golly and gosh, do I have a whole bucket of it, and you can get it for about $150 for the rest of your life. Just I would maybe recommend signing up with a personal email address, because if it's tied to your work email, you know how that goes. If you use the link up there and use that discount code, that will bring the price down to something affordable even for the recently departed. My phone keeps making weird sounds. If you would like to in person see me do various administrative tasks, I will be at SQL Saturday, New York City 2025, taking place on May the 10th in beautiful New York City. Times Square, really the height of New York City, where every subway stops, I think. And there's a full day performance tuning pre-con on May the 9th, given by Andreas Wolter. And he's got some performance stuff he's going to teach the world about. So that's going on. I'm still waiting to hear about shoring up some dates for other stuff. So hopefully I'll be able to expand on some of this soon. But with that out of the way, let's talk about these local yokel variables. Now, let's see if Zoom it works. I'm going to hit Control and 1 here. We're going to see what happens. Wow, first try. So most people use local variables out of convenience. Just purely, hey, I can declare a thing and do something with it. Okay. Some people get it in their heads that local variables fix all their parameter sniffing problems. You'll never have another performance problem so long as you avoid parameters. Do you honestly think that if parameters were that bad that they would just stay in the product as a way to fool you, to ruin things for you? Well, it seems a bit goofy to me. But just like you can't fix a broken bone with some good vibes, you can't fix parameter sniffing with bad advice. We're going to talk more about that later on in the series, but I do want you to be prepared for this eventuality. Like many things that we've talked about so far, local variables have their uses, and they are a convenience for you to do various things with. But when you use them in specific ways, they can really muck up cardinality estimation, plan choice, and ultimately performance. If you are a frequent watcher or viewer of this channel, you're probably not terribly surprised by any of that. You've seen me talk about it before. You may have even read some of my extended thought pieces on the matter. So I do try to balance up the more advanced weird stuff on here. I do have to do some of the evergreen content that hopefully people find and solve some easier, earlier problems for them. But local variables do present a rather attractive proposition for a lot of people who are programming in T-SQL. You can set a constant value for something, like SQL Server doesn't have like domain variables for stuff. And you can assign values from rather complex subqueries to a single variable so that you don't have to recalculate that rather complex subquery over and over and over again. You can also do other stuff for them. They are really handy for loops. When you want to print or raise error, some feedback about how your loop is progressing, things like that. So they are useful for stuff. One of those things where that I am okay with is either using it to like have a consistent batch modification time. This is an okay thing to do for what I'm going to show you, because this sets the batch modification time to one single value. So if you have to update multiple tables to show a batch modification time, then it will be consistent for each step in the batch. Otherwise, the sysdate time call will be recalculated every time it's invoked. So if one batch modification happens like 5 minutes after another one, Well, that they're gonna they might look like different batches because they're spread apart. They don't have the same batch time. And of course, if you need to calculate some rather complex sub-expression and assign that to a variable, it becomes even more important to stabilize that somehow so that you don't get caught re-executing the same thing over and over and over again. That can be not fun, especially if this thing ends up interwoven as a subquery into a bunch of other queries. So where that's okay with me is if you're going to do something like this, where you just need to use that as a scalar value in an insert or an update or something, like where you're just setting a value to something or inserting a value with something, that's totally okay. There are good and convenient and sensible uses for local variables. Where things get a little thrown off is when people start using them down in where clauses. I guess probably far less common would be in a join, but where clauses, you do see them in there quite a bit. Though I do see some people really go out of their way to screwball things by setting a local variable to something and then like joining on a case expression or an or clause, where if the local variable is one thing, you join to this other thing, and if it's one thing, the other, you join to this other thing, and you're like, stop. You stop. This is not going well. But many developers are under this strange impression that parameter sniffing is the worst thing in the world, right? They hear the words parameter sniffing, and all of a sudden, everyone has an opinion, everyone has a feeling deep in the gut, and all of a sudden they are the world's foremost expert on something. It's like when you say optimistic isolation level, and someone's like, "Well, I read a blog post that says it's dirty reads." I'm like, oh, good for you. You're wrong, but stop reading wrong blog posts, I guess. But the real problem that you run into is parameter sensitivity. But local variables are often not a very satisfying fix for parameter sensitivity issues, because while they do remove parameter sensitivity as a performance issue, you do end up with what is a sort of generalized cardinality estimate, which may not fit well for many of your data distributions, depending on if they skew high or if they skew low or something like that. Local variables use an estimate derived from the total rows in the table multiplied by the assumed uniqueness of a column's data. And more often than not, that's either a very small number or a very large number. So if you have the type of skewed data that led you to having these parameter sensitivity issues, that sort of fuzzy guess will either skew high or skew low, and you probably won't get a plan that's very good for one or the other to use anyway. You do remove parameter sensitivity as a performance issue because you are no longer using a parameter, but you are introducing another potential performance issue into the mix by doing so. Every once in a while, this does fix something, and if you want to test it to see if it fixes something across a variety of executions and parameter values with different distributions assigned to them, you can absolutely do that. I don't want to tell you never to do it. I just want you to tell you to test to make sure it's a valid thing to do, because more often than not, it's the wrong thing to do. So this is sort of the effect of local variables. What I'm going to do is clear up the plan cache, because I want you to understand that there is no plan reuse happening here, and the plan reuse is not why we are seeing the same estimate over and over and over again. If I run this loop, when I do have query plans enabled, so we don't have to worry too much there, we are going to get our 8 counts back. And I want you to see that all 8 of these counts return wildly different numbers, but when we go look at the query plans, we get the same estimate across all of the query plans. This will be the same number no matter what. This is not a lack of statistics. We have statistics on the table, or rather for this column. You can see SQL Server using them. If we go to optimizer stats usage, we will have a variety of statistics loaded in, where SQL Server was cardinality estimating for us, right? So SQL Server was using statistics We are not in a statistics-free zone here. But because we use a local variable, SQL Server performs the same calculation for every single one of these plans in order to determine the cardinality of this operation. And of course, this is wrong for every single one of them. We're off by 380% there. We got 167 of 2857030, so 167 of 2.8 million. This particular density vector estimate skews high, or somewhat high, but if you look through all of these, we just get a sort of poor guess for every single one of them. Even on the high side, we're either wrong by 210 or 388%. So this isn't a very good thing either. This would be the same thing if we were to use optimize for unknown, right? This is like the same basic effect here. Now, if we throw option, like what I was talking about earlier, if we throw option recompile on this, we will get the same counts back. And you will see that SQL Server all of a sudden is capable of garnering us precise cardinality estimates. Here we hit, well, we're close enough to right there. We're dead on there. We're good here, right? Well, we're off by like, what, 12 or something? 22, 12, something like that, some math. But like SQL Server is able to get very close to the number that we care about for all of these, right? So SQL Server does have good statistics to calculate that, but it doesn't do that calculation. It doesn't look at the histogram when you use local variables or when you use optimize for unknown. It does not do that. You do not get a view of the histogram that SQL Server has for a column. We just get the two components of the histogram, the number of rows in the table and the assumed selectivity, and those get multiplied together. The percentage that SQL Server uses will be different across equality predicates, so direct column equals something like we're using here, versus inequality predicates like greater than equal to, less than equal to, or not equal to. You get all different stuff for those. But sometimes what happens is people use local variables in a way where, because of some other predicate, it could be a parameter, it could be a literal value like we're using here, but because there are other predicates in the query, the effect of the local variable gets tamped down quite a bit. So if we look at these two queries, and I'm forcing SQL Server to use the clustered index here, but what's important to note is that the index that you use to fetch data from is not always the index or the statistics that you use to perform cardinality estimation for the query. SQL Server may choose a completely different statistics object with a better sampling rate or something like that to, or a more recent update, fewer modifications, something like that, in order to do the cardinality estimation. So for these two queries, where in one of them I'm using a local variable, the other one I'm using just a literal value, you'll see that the cardinality estimates for these are not terribly far off, right? We get the same count result back, but when we look at the query plans, and if SSMS will listen to me, pretty please, there we go. The cardinality estimates for these two queries, one using the local variable and one using the literal value, they're not terribly far off. Right, 15,282 versus 15,606. Was either one of them particularly close? Not very, but this is kind of what happens to a lot of people. They'll use a local variable in a spot where they have other parameters that sort of make the cardinality estimate look closer than it is, and maybe they don't realize that there is a difference and how SQL Server estimates cardinality for these. So while there is a small difference here, it's not so profound that it would change much about the query plan in a way that you would notice. So when you want to test whether something you're doing is okay, the hardest part really is understanding what options you have available to you that may produce different results. There are many ways to pet a dog. I don't want to say the thing with cats. Many ways to pet a dog. Up here, behind the ears, near the butt. not like like above the tail. Stay above the tail. Don't go below the tail. If you go below the tail, I don't know what's wrong with you. But there are many ways to work with SQL Server to figure out if what you're doing is the smartest thing that you could possibly be doing. But like I said, the hardest part is really knowing that what you're doing might not be a good idea, and understanding what all of your options are in these cases. A lot of this is why when you look at a SQL Server code base and you find a problem, you see that problem repeated everywhere. That's how various things that just are like pervasive. It was like issues with T-SQL code that I look at just ended up all across it, right? Code is culture. The second something yucky ends up in the culture and no one knows any better, or people are afraid to like do anything with it or do anything different or touch it or get away from it or say, hey, that's not good. That one instance ends up everywhere, right? And that goes for a lot of things. That goes for like stuff like no lock hints, table variables, common table expressions, scalar UDFs, multi-statement UDFs, and people wrapping like overprotectively every single column and every join and where clause with like is null, coalesce, stuff like that. And like there's like undoing all this stuff is a long process, right? Because like it's just absolutely everywhere, and like especially if it's in the UDF territory, you have to like not only rewrite the UDFs in a lot of cases, but you also have to change the way that the queries call those UDFs, because invoking a table-based UDF is a lot different from the way you call a scalar UDF. And of course, local variables are on this list. So what I want to show you here is sort of more explicitly how some of the stuff that I showed you can end up causing a performance issue. I've got a couple indexes created on the post table, one on the parent ID column and one on the owner user ID column. And we are going to create or alter this store procedure here. And then we are going to run it. And while it runs, I'm gonna show you the different ways that things are going in here. Oh, you know what? I have an extra index that I forgot to drop. So we are going to really quickly pretend that didn't happen. P2 on posts, because one thing that I was going to show you later was how compound indexes can help stuff a little bit. But for now, we're going to return to Narnia here. So while this runs, we are going to have one expression of the query where we're using two literal values. We have one expression of the query where we are using two parameter values, right? These are the parameters that got passed in up here. And then we have another one where we are using local variables that got assigned the parameter values that got passed in. That's what we're doing right here. All right, this is what I catch a lot of people doing with a little comment that's like, fix the parameter sniffing, boss. And then down here, we are using the optimize for unknown variant, which gets you the same cardinality estimation effect of using the local variables. And if we look at the execution plans for these, this one turned out okay, right? Fine with this. 817 milliseconds, fine with me. 851 milliseconds, again, fine with me. This is for the literal values. This one is for the directly used parameter values. But down here, we have two very different query plans, right? Rather than using each of the non-clustered indexes that we originally created individually, we have the P1 and the P0 being used. These two just do a more classic index seek plus key lookup here and here, right? You can see the little key lookup operator, and these take significantly longer. These are about 11 seconds a pop. And this is specifically because SQL Server did a sort of a bad job of estimating what would be the best set of stuff to use here. So this is one of the, like, just an example of how when you use local variables, when you use optimize for unknown, you do not always end up with the best execution plans. So across all that, it's important for people to know how they can test code effectively. Now, not all code comes from a stored procedure. You might be dealing with an environment where ORMs are in use, and they are hopefully passing in parameterized queries. Right? One would hope anyway. So what I'm going to do is show you how you can test that code effectively. So if you're troubleshooting a performance issue, you want to make sure you're troubleshooting the correct performance issue. So I've got two queries here. I'm going to show you one of them. And I'm using my store procedure, SP Quickie Store. You can get this at my GitHub repo. And I'm searching for a couple of different query IDs. No particular reason for these, just that they are fairly good examples of what an ORM query might look like in Query Store. And I'm just going to click on this top one. So when you click on this, you get the full query. And if we go and highlight this whole thing, except for that little question mark doodad down there, we can plop this right into our query editor window. Now, of course, we can't execute this as is. We would get all sorts of errors. But what you might notice here is that we have what looks like the beginning of a stored procedure. Now, one thing that SQL Server does allow you to do is create temporary store procedures so that you can have just like effectively what you would get from like parameterized SP execute SQL, which is the way most ORMs work. And if we just say create or alter up here, and I'm just going to call this $P just to keep it short. And all we have to do is come down here and stick an as right there. Now, just to make life a little bit easier, let's put these on new lines. So when we assign values to them, it'll be a bit simpler. And now we're going to need another thing from the query plan, right? What's that other thing that we're going to need? Oops, that didn't go well. There we go. The other thing we're going to need from the query plan is the parameter values. So if we come back to the query store results, and we open up the query plan, there are two ways for you to go about this. You can either right-click, tooltip getting in the way, we can either right-click on the select operator, and we can go to the parameter list, and we can see all the values that we care, all the compile values that we care about in here. All right, but if there's a bunch of them, it gets a little tedious copying and pasting back and forth. So what I usually do is show execution plan XML, bomb all the way to the very bottom, and copy out this block. And once you've got this block copied out, you can get rid of the query plan. Right? We can paste this up here, and now all we have to do is line up the parameter names with what we have down here. So offset equals 0, and fetch equals 50, and end date equals 2014, blah 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 blah. So we're going to put that here. And start date equals 2013, blah, 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 blah. And so we're going to put this here. And now we can create or alter this store procedure with those as the default values. And if we just say execute $P, we will get a working store procedure that effectively mimics the way a parameterized ORM query would run with SP execute SQL. SP execute SQL and this are a completely the commensurate equal way of doing things. One thing that I do want to bring up though is depending on the ORM you are using and how that ORM operates, you may need an additional piece of information. So one thing that Quickie Store returns way over here in the results are the context settings for your query. So any context setting that you see here would be on in the query. So if anything is not in here, you would have to look at the ANSI settings and you would have to set that to off. These are generally the ones that you would care about. So this usually the one that ORMs have off that they may want to have on is arithmabort. So just be very careful with, usually if you're testing against ORM stuff, you want to turn arithmabort off so that you get the same either cache hit or something for them. It's not going to fix your parameter sniffing problem, but it will at least bring you to the query, like usually get you the query plan of the thing you are testing. So that is how you can effectively test code without falling into the local variable problem that we've been discussing for this last, 30 minutes. Jeez Louise. Got ahead of myself a bit there. Anyway, should probably wrap this one up then before the camera starts to overheat. Lord knows, most people start to overheat if they look at me long enough. So thank you for watching. I hope you enjoyed yourselves. I hope you learned something. And I will see you in the next video where we will talk about how you can use wrapper procedures. You can see that over there, to alleviate some problems with things that we talked about, like when you have a bevy of local variable assignments happening, and you need to use those local variable assignments in other queries where cardinality estimation would matter. So I'm going to go prepare those demos. Hopefully, not forget that I created any indexes, and we'll go from there. All right. Thank you for watching.